Let's look at this problem. A skier with mass of 62 kg is sliding on a snow at a constant acceleration. Find the coefficient of kinetic friction for the skier if the friction is 49 newtons. So we have to determine the kinetic friction coefficient if we've been given the friction between the skier and the snow. So the friction given here is kinetic friction, since we are determining the coefficient of kinetic friction. So now let's look at the solution for this problem. So we state out the parameters we have in the question. So we have the mass for the skier, then we have the kinetic friction, which is 49. The mass is 62 kg. So we know that kinetic friction Fk is equal to mu k times n, which is normal force. So we're supposed to determine the normal force before we can find the kinetic friction. So with the normal force, we know that the normal force is equal to the weight of the skier. The weight of the skier. So for us to determine the normal force, we are supposed to multiply the mass of the skier by the acceleration due to gravity. So therefore we're having the normal force to be equal to 62 times 9.8. 62 times 9.8. After computing, you're having the normal force to be equal to 607.6 newtons. So normal force is equal to 607.6 newtons. So now that we have the normal force, we can therefore substitute into the equation, then we get the coefficient of the kinetic friction. So since we are determining the coefficient, we are supposed to make mu k the subject of the relation. So therefore you're having mu k to be equal to Fk over n. Having mu k to be equal to Fk over n. So therefore we do the substitutions into this expression. We're having 49 newtons, which is the kinetic friction, over the normal, which is 607.6 newtons. After computing, you're having the kinetic friction to be equal to 0.08. You're having the kinetic friction coefficient to be equal to 0.08. The coefficient has no unit, since the friction force is dividing the normal force, and their unit will cancel out. So the kinetic friction coefficient is unitless. So this is how we go by to determine the coefficient of kinetic friction. Now let's look at another question, which is a 30 kg crate is at rest on the floor. The coefficient of static friction between the crate and the floor is 0.70. Find the force of friction between the crate and the floor. Find the force of friction between the crate and the floor. So we are finding the force of friction of a crate at rest on the floor. So since the body is at rest, we know that the force or the friction between the crate and the floor is the static friction. So therefore we are determining the static friction between the crate and the floor. So into the solution, we state the mass, which is 30 kg, and the coefficient of static friction, which is 0.70. The equation we are using is Fx is equal to mu x times n. Fs, which is the static friction force, mu x, which is the coefficient of static friction, then n, which is the normal force. We are therefore supposed to calculate for the normal force, which is equal to the weight. So mass of the crate times acceleration due to gravity. So therefore we're having 30 times 9.8. So the normal force is 294 newtons. So this is the weight of the crate. This is the weight of the crate at rest. So we substitute the normal force and the static friction coefficient into the equation. That is 0.70 times 294. So the static friction between the crate and the floor is 205.8 newtons after computation. It is 205.8 newtons. This means that the friction force between the crate and the floor is 205.8 newtons. So to be able to accelerate the crate, the force applied to the crate should be equal to or greater than 205.8 newtons. So if you want the crate to accelerate or the crate to move, the force that will be applied onto the crate to be able to break the static friction force between the crate and the floor must be greater than 205.8 newtons.